To whip up some dishes, a batch feeder pushes ingredients into a big furnace as they spill out of a bin overhead. Silica sand is the biggest part of the mix. It's a crystalline substance and it makes glass transparent. The batch also includes soda ash and recycled glass. Some of the other ingredients are a trade secret. The furnace heats the mix to the melting point, over 1500 degrees Celsius. It turns into molten glass that looks like lava. The glass, in this lava-like form, will spend up to 24 hours in the furnace. On its way out, mechanical shears cut it into gobs. The gobs slide down a water-cooled chute and drop into a baking dish-shaped mold. There are 16 molds on a rotating table. As it turns, the table delivers the gob-filled molds to a plunger, which presses them into the baking dish shape. Continuing to rotate, the table positions the molds under blowers. They cool the freshly molded glass so it holds its shape. A mechanical arm suctions up the glass dish and sets it down on another revolving table. Flames lick the glassware from burners above and below. The dish is exposed to a temperature of over 1000 degrees Celsius. This softens its sharp edges so that the rim is smooth. Next, hoses blast high-pressure air, cooling the dishes to solidify them, so that a mechanical arm can pick them up without ruining them. It transports the glass dishes to a conveyor belt. Further down, another arm feeds the dishes to a kiln, where heating and cooling cycles temper the glass. This is what gives Pyrex its strength. Now it's time to put a lid on things. A different plunger presses glass gobs into a lid shape. Every lid needs a knob, so a valve inside the mold forms it and then thrusts the lid up to be picked up by a mechanical arm. The arm flips its lid and sets it down on a conveyor belt. The lids are on the move, traveling through a tempering kiln. On their way out, a fan cools them off so they can be handled by human hands this time. Workers inspect each glass lid before packing them. On another line, there's a product that's made to measure. Little platforms lift the measuring cups to suctioning arms that protrude from a revolving silkscreen machine. A little squeegee forces enamel through a screen, printing measurements onto the cup. Over in the lab, a worker roughs up a sample dish. By rubbing it with sandpaper, he mimics years of wear and tear, but it's about to be subjected to even more abuse. He places a sharp tool in the center of the dish and takes aim with a hammer. Will it break without shattering into numerous little shards? It's a clean break, which means this dish has met the quality standards.